again, this is a review not only for what you need for the group assessment tomorrow, but also what you're going to need for Tuesday. So as we go through, make sure you're writing down the correct answers, any additional tips or hints that I write down. And of course, if you have any questions, then let me know. So starting here on number 1, looking at the graph, does it have one real solution, two real solutions, and two imaginary solutions? Hopefully you remember that if you're looking for solutions, you're going to be looking on the x-axis, which I've highlighted there for you. Your quadratic will either intersect it exactly once, in which case you'll say one real solution, exactly twice, in which case you would say two real solutions, or it will never intersect, in which case you would say two imaginary solutions. And it looks like that it does not intersect it, which means two imaginary solutions it is. Not only should you be able to answer a question like that just by looking at the graph, but you should also be able to answer question B. So if you have a graph that doesn't touch the x-axis and has two imaginary solutions, does anybody remember what does that tell you about the discriminant? Is it greater than 0, less than 0, or equal to 0? Anybody who can remember and tell me? I'm sorry, say it again.
Less than.
Less than, perfect, thank you. And just as a reminder, so two imaginary goes with less than. Just in case you wanted a reference here, one real solution goes with equal to, and then two real solutions would go with greater than. So just in case you want to have all the combinations there. So any questions on number 1? Okay. Number 2, so which choice below represents the vertical motion model where an object is launched upward with a velocity of 8 feet per second from a starting height of 12 feet? So you might want to remind yourself the vertical motion model is as follows. H of t equals negative 16t squared plus v sub 0 t plus h sub 0. Remember that the negative 16t squared is because of gravity, and that doesn't change as long as it's in feet. V sub 0, that's the starting velocity, either positive if it's going up, negative if it's going down, or 0 if you're dropping it. And then h sub 0 is the starting height. So from what height is the problem starting? Looking at those 4 choices, A through D, does anybody think they can identify for me which one represents launching an object up with a velocity of 8 feet per second from a starting height of 12 feet?
C.
C, perfect. Questions? And I'll just highlight that to be sure. Okay, without actually even solving the problem, let's say that I did give you a vertical motion model and I asked you to find how long it takes for the object to hit the ground. What is the value of the height when an object hits the ground? 0. Remember, hitting the ground, hitting the water. When does the object stop? That all just means that the height is equal to 0. Once you set the equation equal to 0, you can either solve it using a graphing calculator, or you can solve it using the quadratic formula or factoring. Again, without actually solving it all the way through, number 4, if I was to ask you for an object's maximum height, what do we call that point on a quadratic? The maximum height is also known as the what? Vertex. And as a reminder, the formula for vertex is negative b over 2a. Normally, it's x equals negative b over 2a, but usually since it's time, I'm going to say time equals negative b over 2a, although it wouldn't really matter either way. You guys were good at the word problems back when we did them, so I think you could solve problems all the way through, but here just reminds you of the setup. So any questions on 1 through 4? And again, tomorrow in your group work, you can have your notes. So, have them handy just like always. Okay, so number 5, you're playing a game of horseshoes. One of your tosses is shown in the diagram below, and then they give you the equation. So y equals negative 0.01 x squared plus 0.3x plus 2. Oops, sorry. They're telling you that this is not a time problem. They're telling you that x is how far you can throw the horseshoe, and Y is how high you can throw the horseshoe. So they give you a little bit of a visual there. And of course, they give you an equation. Remember that if it's not feet per second, or sometimes even if it is, if there is some other equation other than negative 16t squared, they have to give it to you. So there it is. And I'm telling you that in this one, we are going to use the graphing calculator or Desmos. For tomorrow, there might be some that say use a graphing utility, in which case you can take a picture of your graphing calculator, or you can sketch it, or you can show your Desmos snippet, or if it just says solve using any method, you can do the algebra. So the questions are, what is the height of the horseshoe when it is 2.5 feet away from you? And then will the height of your throw ever reach 5 feet? So there's a couple different ways that you can answer these. We're going to go ahead and go to the graphing calculator. So again, if you are somebody who has a graphing calculator, you should have it in front of you. If you're someone who uses Desmos, you could always be pulling that up on a separate window, or you can just listen. So I'm going to go ahead and go to my Y equals, and then I'm going to very carefully type in the equation. So Y equals, again, make sure that you choose the negative and not the minus, 0.01 x squared plus 0.3 x plus 2. Double check that you have entered it incorrectly, and double check that there's nothing else anywhere in those Y's. In terms of the graph, if I press the top right graph key, I may or may not see what I expect to see. It all depends on the window. I know based on the picture that I gave you, it's supposed to look like an upside down quadratic. It kind of does, but not exactly. So if you want to fix that, you are going to press the window button. And then for the window button, you have to use some common sense. So this is a problem about how far and how high a human person could throw a horseshoe. So again, negative values don't make sense, although I personally always like to leave a little bit in there. So I'm just going to say -5, just so I can see a little bit. In terms of the X maximum, it's how far do you think a human person could throw a horseshoe, and then maybe a little bit extra. Let's say you have someone who's a real stud, and let's say 50 feet. I'm sure that's way too far, but better safe than sorry. Again, the Y minimum, you're not going to throw the horseshoe underground, but it's good to have a little bit of negative, so let's stick with -5. And then again, how high do you think a human person is going to be able to throw a horseshoe? Again, 50 seems ridiculous, 50 feet, but it's okay to be a little bit higher as long as you're not too low. And again, if you said 40 or 30, probably that would work as well. You'll know if it works based on when you press graph, if it looks the way that you expect it to. So looking at this, I can see that my Y values are way too big. I have all that dead space in the Y zone. So if I want, I can go back to the window. Instead of 50, I'm going to change it to 25. And if I go back, you can see it kind of fits a little better. Even that is still, there's a lot of dead space. So if I don't like that, instead of 25, maybe only 15. And then just notice it fills the screen a little bit better. But again, any of those will be fine as long as you can see the curve. Any questions on any of those maneuvers?
No, but what are we trying to answer in this problem?
So we're answering A and B. So now it says, what is the height of the horseshoe when it's 2.5 feet away from you? So if you want to find the height of the horseshoe when it's 2.5 feet away from you, you need to find a value. So you're going to press second trace. You're going to choose value. You're going to choose 2.5 for X. And when you hit enter, it's going to show you where the ordered pair is, and it's going to tell you the corresponding Y value, which is 2.6875. So if I go back to my class notebook here, again, I am choosing based on the graphing calculator, the value. So that's 2.5, comma, 2.6875. And what is the height of the horseshoe? So the height of the horseshoe is this. You can round it if you want. So I'm going to say 2.7 feet. Questions? And then there's a couple different ways to answer B. Will the height of your throw ever reach 5 feet? Say yes or no and give a specific value. So you can't just say yes or no, you have to say why. Here's one thing you could do. If you want to know the highest that this graph ever goes, you could find the maximum, and then is it greater than 5 feet? So going back to the calculator, remember all the good stuff is in that same spot, second trace. I'm going to calculate the maximum. So I'm going to be close to the maximum, but on the left. Then I'm going to be close to the maximum, but on the right. What you're doing is telling the calculator to find the answer between those two dotted lines. You don't have to guess. One more time will give you the answer. So it looks like the maximum is 15, 4.25. So if I go back to my graphing calculator, I can say that the maximum or the vertex is the point 15, 4.25. And then answer the question, will the height of my horseshoe ever reach 5 feet? Yes or no? Anyone?
No.
No, because the maximum is 4.25 feet. Just to be clear, one other thing you could have done if you wanted, go back to the y equals. In the second slot, put a 5. Go back to the graph. See how the blue curve never reaches the red line? You also could have said that, and you'll be able to see that it never reaches that height. So any questions here? And a reminder, second trace, that is where all the good stuff on the calculator comes from. Or, of course, Desmos works as well, and we found both a value and a maximum. So any questions on number 5? Okay, so then on to system. So that was basically the lesson on word problems. Remember, there was a day with a calculator and a day without. So now let's talk about systems. The first way that you solved a nonlinear system was by graphing. And again, if you're going to do that, you can use a graphing utility. But here I kind of switched it up a little bit. So what I did for you to start is I graphed the quadratic for you. It's here. Just to make sure you understand why it looks the way that it looks. I know that it faces up because it's a positive. I know that the y-intercept is the point 0, -3. I know that I can factor this as x minus 3, x plus 1. And if I set that equal to 0, that's how I get these two x-intercepts. So just as a reminder why the yellow graph looks the way that it does. I want to go ahead now and I want to graph this line, which I'm confident that you guys could do, but let's just make sure. So how do you graph y equals 2 over 1x minus 3? Well, hopefully it hasn't been that long. You're going to start at -3. You're going to go up 2 and right 1, up 2 and right 1, as many times as will fit on your graph. And then you're going to go ahead and connect them. When you do that, you're going to go ahead and, again, let me just make sure I got it color-coded for you. So there's the line. You're going to go ahead and identify the points of intersection, and the points of intersection are where the two graphs meet. So hopefully you can see that that's here and here. That means that your answer to this problem is the point 0, -3, and the point 4, 5. Remember that you could do that on Desmos. You could do that on the graphing calculator. You would have to do it on the graphing calculator by doing second trace and then choosing the intersect feature. And then just as a reminder, if you wanted to check those answers, you would plug them each into the yellow and see if they work. Plug them both into the blue and see if they work. But I can promise you that they do. So solving by graphing literally means graph them and locate their points of intersection. Most of the ones we've done have had 2, but it's perfectly fine to only have 1. And it's also perfectly fine to have none. So any questions on solving a system by graphing?
Yeah, when we factored it, why was it x minus 3 and x
Oh.
plus 3? That doesn't make negative 2.
Yes, nope, you're correct. That should be x plus 1. Thank you. Just a little slip of the wrist. Thank you.
If there were 0 points of intersection, what would we write?
No solution.
Okay.
Other questions? Okay, number 7. So now use elimination and check by graphing. So I have the graph for you, which again, I made on a graphing utility. I can clearly see where the points of intersection are, but I want to go ahead and do elimination. So if you're trying to do elimination, remember the whole point is that you want one of the variables to cancel out. Here's where it gets a little bit tricky. So in this problem, you can see that the x squareds are in fact opposites, but if you were to add those together, you would be left with x's and y's, and we don't really like that to happen. So we're actually going to try to get the y's to be opposite instead. So what I'm going to do is I'm going to multiply the first equation by a negative 1. That's going to turn it into a negative y, a negative x squared, or sorry, a positive x squared, a 0x placeholder, and a negative 6. So again, just to be clear, I'm going to multiply that first equation by a negative 1. That gives me a negative y, a positive x squared. Since there is no x, I'm going to do a placeholder, and then I'm going to make that last 6 into a negative. The whole point of elimination is you want one of the variables to eliminate. So as I add these together, notice that the y's cancel to give me a 0. X squared plus x squared is 2x squared. 0x plus 4x is 4x. And then lucky me, the 6 is canceled as well. So now I have to solve. The best way for me to solve is to factor out the greatest common factor. Does anybody know what the greatest common factor is?
2x.
Thank you. And you're left with x plus 2. You're going to set each parentheses equal to 0. So if you set 2x equal to 0, you're going to get x equals 0. If you set x plus 2 equal to 0, you're going to get negative 2. Your answers are 0 comma something and negative 2 comma something. In order to find the something, you have to plug these x's back into either of the original equations. I'm going to choose this one. So I'm going to say that y equals negative 0 squared plus 6. That, of course, would just be 6. Then y equals negative 2 squared plus 6. Be a little bit careful here. Order of operations. First square the negative 2, which makes a positive 4. Then multiply by the negative, which gives you a negative 4, plus 6 is 2. So those should be your 2 points of intersection. And I think you would concur 0 comma 6 and negative 2 comma 2. Looks like we hit it right on the money. So elimination means you need a pair of opposites and you want them to eliminate. Any questions on number 7? Okay. Number 8 was all about substitution. So in substitution, you literally have to plug one value into another. And because this y is already isolated, I'm going to plug the y equals into the y squared in the second one. Reminder that x squared plus y squared, that's a circle. You don't have to be able to do anything with circles other than just be able to manipulate them algebraically. This guy here in the squared, please make sure you remember that that's a FOIL. So x squared, if I FOIL, so negative x minus 3 times negative x minus 3, that's going to give me a positive x squared, a positive 3x, another positive 3x, a positive 9, and that's going to equal 17. Combine all the like terms, 2x squared plus 6x, and then subtract the 17 from 9 to give yourself a negative 8. What do all three of those values have in common? Thank you. I'm going to divide by 2. And then look at that. It does, in fact, factor. Two things that multiply to be negative 4 and add up to be positive 3 would be x plus 4 and x minus 1. That is still equal to 0. So that's going to give you x equals negative 4 and x equals 1. Just as a reminder, that is only part of your answer. To find your whole answer, you would have to do negative 4 comma something and 1 comma something. To find out what the somethings are, you would have to plug those into either equation, preferably the first one. So if I plug it into y equals negative x minus 3, a negative 4 is a 4, minus 3 is 1. So that's the point negative 4, 1. And if I plug a 1 in, negative 1 minus 3 is negative 4. So my two answers are negative 4 comma 1 and 1 comma negative 4. Again, it doesn't always have to be two solutions, but for some reason that just always seems to be the standard. But if you have fewer, don't worry, you're not going to have more though. Questions up to there? Okay, the last couple things are about inequalities. And while you might see inequalities on the second day, I don't think you're going to see them tomorrow. So in terms of studying, you pretty much have to know up through number 8. So for number 9, what I have for you there is I have the equation y equals, negative x squared minus 2x plus 15. Then I have a quadratic inequality there. And I basically want you to change this from an equals to the appropriate signage. So the answer should be y and then negative x squared minus 2x plus 15. And basically, I'm trying to figure out what goes in between them. Should it be a greater than, a less than, a greater than or equal to, or a less than or equal to? So a couple different ways for me to decide that. But again, a couple of other reminders. How did I take this equation and turn it into a graph? Well, the 15, that's the y-intercept. Notice that it faces down because there's a negative out front. If I was to set this equation equal to 0, I would start by dividing everything by a negative, just because I like there to be a positive out front. Factors of negative 15 that add up to be positive 2 would be plus 5 and minus 3. And then notice the x's would be negative 5 and positive 3. So that's where the x-intercepts come from. So I just want to make sure you understand. So here are my 4 choices. Less than or equal to, greater than or equal to. And it's basically one of those 4 choices has to go in that yellow slot. Take a look at the graph. See how it's a dashed line and not solid. Does anybody remember if it's a dashed line, should it have an equal to, yes or no?
No.
So not this one and not this one. If you were a person standing on the graph, see how the shading would be above your head. If the shading is above, do you think I should choose the less than or the greater than?
Greater.
Would be correct. And that's what I'm looking for.
Wait, Mr. Pinsky, what was the point of factoring it if you could just tell by it being above that it's greater than?
The whole reason why I showed you the factoring, I just want you to understand where these red points come from. Like, what if tomorrow I didn't give you the graph and you had to make one? I just want you to understand where they come from.
Oh, okay.
Anybody else? Guys, is this helpful?
Yes.
Okay.
Yes.
Perfect. All right. Couple more problems to go. Number 10, match the inequality with the graph. So you have 4 equations and you have 4 graphs. Notice that some of them are shaded above, some are below, some are positive, and some are negative. Again, notice that each of these is just a single quadratic. So if there's just one quadratic, then there's just one picture. Of those 4 choices, there's actually one I should be able to match immediately because it's not like the others. Anybody can tell me which one, obviously, do they know the answer to and why?
4 and A.
4 and A, how come?
Because it's upside down and there's a negative in the front.
Perfection. So 4 has to be A because of the fact that there is a negative out front. Notice again that because this is a dash parabola and you're shading above, that's how I know that it's just a greater than. Okay, cool. Now take a look at the 3 that are left. In the 3 that are left, 2 of the quadratics are the same and 1 is different. So I'm going to start with the one that's different. So factors of positive 3 that add up to be negative 4. Anybody can tell me?
-3 and -1.
Thank you. So that means the x-intercepts have to be positive. The only one that has a positive x-intercept at 1 and 3 would be graph B. So I know that this has to be B. And again, just to be clear, this should be a dashed line and it's shaded below, which is why it's a less than. Process of elimination, it's the same quadratic, but 1 is less than or equal to and 1 is greater than or equal to. So can anybody tell me number 3? Should 3 be C or D?
C.
Okay, and it's because it's solid and it's shaded below. So that's how I know it's less than or equal to. And then for the last one, it is solid and shaded above, and that's how I know that it's D. Okay, I'm loving the responses. Thank you. I think it helps. So again, those are just quadratic inequalities, and the hardest it can get is number 11. This is a system of quadratic inequalities, which means there are 2 at a time. So notice you have the blue parabola, which faces up. It's shaded above and it's dashed. Notice you have also the red parabola, which is dashed, facing down and shaded below. When they ask you to list 2 solutions of the given system, does anybody remember where do the solutions lie if there are 2 parabolas?
In between the red and the blue.
And so I'm going to call that, just for argument's sake, the shared shaded region. So any value in the shared shaded region is going to be an answer to this system. It asks you to list 2 solutions. Can anybody look at that yellow shaded area and tell me any point that they are confident lives directly inside that shading?
3, 7.
3 comma what?
7.
3 comma 7. So that, if these are counting by 2, 4, 6, then I don't think 3, 7 works because it's just above.
Okay, well then it's 3, 4.
That sounds better. That would be right here. Anybody else can tell me with 100% confidence a second point?
3, 1.
4.
And then just so you know, it varies. Obviously, those are just 2 of infinitely many. Questions? Okay, last one. So on the left, consider the graph ax squared plus bx plus c, so no numbers. And then notice you have two x-intercepts that are called x1 and x2. You don't know the numbers. So in question A, what are the solutions of the quadratic being less than 0? So if you are going to answer this being less than 0, you want to know where the graph is under the x-axis. So the graph is under the x-axis everywhere that I made red. So starting at x1, ending at x2, that's interval notation. Remember the first answer, comma, the second number. And the reason why it's parentheses is because there's no equal to. If there's no equal to, you use parentheses instead of a bracket. The opposite of being less than 0 would be being greater than 0. So in question B, when they're asking you for greater than 0, they want to know where you are above the x-axis. So the graph is above the x-axis everywhere that I made purple. So how do you say, oh, sorry about that, pressed a button. So you basically want to say to the left of this and to the right of this. Because remember, you're giving x's. So how do you say to the left of x1? You say negative infinity to 1. Oops, sorry, x1. Take a break means union, and then from x2 to infinity. Remember, your answers are x's. So in part A, it's from x1 to x2. And then in part B, it's from the smallest possible x to x1, and then from x2 to the largest possible x. For the final point, it says, suppose you have a reflection in the x-axis, then where will the graph be positive? So if you're going to have a reflection over the x-axis, this graph is going to flip upside down. Where is the graph now above the x-axis? And I think hopefully you would agree that it's from x1 to x2. So I'll put a little star next to 12. I don't know that you'll see one like that tomorrow. It's just kind of a fun question I thought would be good to review.